Okay, this is going to be more trig identities. This is from section 1.5, and so we're going to be going a little bit more in depth. Last section, I think there was just a surface level that we touched when we started talking about the manipulation of the different sides. Last time there were a couple of different ways to solve things. There were a couple of different methods you could use to get to the point that you wanted to be. But now we're going to be talking more specifically about the identities themselves and how to use them. It would be a good idea for you to go through, take a note card or some sheet of paper and put all these identities on one, preferably a note card. Make sure you are using those identities and you have them easily accessible. It's not fun to flip back in your book. It's not fun to have to look them up on the internet. So have them on a note card so they're easily accessible for you. So here we go. More on identities. What we're going to be doing here, and once again, we've got these funny little tangents, or these funny little thetas, so I'm going to be cleaning those up as we go. So we want to write tangent in terms of sine theta. Here's our goal. And if you don't, let me rephrase. I want you to see a lot of things from these videos, but if you get one major key theme from this video today, I want you to get our goal. And this is our goal. Our goal is to get everything in terms of sine theta and cosine theta, if possible. Okay, so if possible, we want to use identities to get everything in terms of sine and cosine. That's our goal, because we're basically, by saying we've got it in terms of sine and cosine, we're boiling it down to its very nature. So instead of using cotangent, cosecant, secant, things like that, tangent, we don't want those. We want to try to put it in terms of sine and cosine. And I think you'll see, if you master this skill, this is going to make your life a lot easier. And so we're going to practice that right now. We're going to write tangent in terms of sine and cosine. Okay, we're choosing just sine in this case. So here's what we need to do. We're going from tangent. So first, what I want to do is I want to get rid of the tangent. Okay, and we're going to try to write it in terms of sine and cosine. Okay, so tangent theta is sine theta over cosine theta. Now, I now have two pieces that were once one. That's okay though, because I'm closer to sine. Remember, I'm writing it just in terms of sine. I'm closer now because I have no more tangent. So now I'm working with this. Let's recall. If I'm going to try to write it in terms of sine, this part is good up here. So I'm going to bring this over. Now, the bottom part, I need to write this in terms of sine. Okay, my goal is to write this in terms of sine because I've already written the top in terms of sine. So what I need to do is recall an identity. An identity that takes sine and says, or should say takes cosine and says it's equal to this, which only has sine in it. So we're going to recall that cosine theta is equal to plus or minus the square root of 1 minus sine squared theta. Do you see what I just did right there? Okay, so instead of cosine, I'm going to use this. I'm going to bring this up and put it in the denominator, plus or minus the square root of 1 minus sine squared theta. And now I'm done. This is my answer because I've written it in terms of sine. You see what I did there? So my first step was to write it in terms of sine and cosine if possible, and then move it to exactly what I wanted. Okay? That's the gist right there. Okay? And so when we go on, we're going to write secant theta times tangent theta in terms of sine theta and cosine theta. This is where a knowledge of those identities is very, very crucial. So let's see what we've got. Secant theta. And if you've got your identities handy, you can recall that secant theta is really 1 over cosine of theta. Look what I'm doing. I'm systematically eliminating, because remember my goal to get everything in terms of sine theta and cosine theta. Well, that's what I'm doing right now. I'm writing it in terms of sine theta and cosine theta. So now, instead of secant theta, tangent theta, what do I have? I have 1 over cosine theta times tangent theta, right? Because 1 over cosine, this is really secant. Okay, now let's do this. Tangent of theta, if only I could write that in terms of sine and cosine itself. Let's see. Oh yes, it's really equal to sine theta over cosine theta. Now watch what happens. So instead of tangent, I want to put that in here. So now I've got 1 over cosine theta times sine theta over cosine theta. See what I did there? I substituted. I'm substituting. Okay, and so now what do I have? I'm going to simplify, and this is where your fractions come in handy. I've got 1 times sine theta, which is sine theta. And on the bottom, I've got cosine theta times cosine theta, which would be cosine squared theta. Done. Okay, so I've written secant theta, tangent theta in terms of sine theta and cosine theta. Okay, now another example. Which would you rather have? A $1 million upfront payment on the first of the month, or an incremental payment system where you get a 1 cent payment on the first month that doubles every day? Okay? Think about that as we add these. That's just a little side note there. We're going to add one over cosine theta plus 1 over sine theta. Now, we're going to recall adding fractions. The key is a common denominator. Okay, so we need a common denominator. How do we accomplish this? Let's check this out. Remember, to find the common denominator, I'm just going to take a product of both denominators. So what I'm going to do here is I'm going to say this is 1 over sine theta times cosine theta over cosine theta, because remember that's really just 1, so I'm multiplying by 1. And when I come down here, I'm going to have 1 over cosine theta times sine theta over sine theta. What I've just done there is multiplied each by the equivalent of 1, but now my common denominator, I'm even going to write it in blue. My common denominator is cosine theta times sine theta. And so when I add these, really what I'm adding is, this is really going to be 1 times cosine theta. So it's cosine theta over sine theta, cosine theta. This is really, let's make the thetas a little bit neater, sine theta over sine theta times cosine theta. Okay, so let's look at what I've got. When I add those, and what I'm going to do here when I add is I'm going to say I've got cosine plus sine theta over my common denominator. Guys, it's substitution. It's finding common denominators. Okay? I'm finding a common denominator every single time. That's all I'm doing. That's all I'm doing, guys. I'm finding a common denominator, and I'm taking my time and substituting out, converting to sines and cosines. Okay? Don't be afraid of this. It's a beautiful thing. Now, what's happening here? Remember that sine theta and cosine theta and tangent theta, they're all really just things that they're numbers, but they need to be multiplied like anything else. And so when I have two things next to one another like this, I can multiply. Recall this FOIL method. So I'm going to have sine squared theta And then I'm going to have minus 5 sine theta plus 2 sine theta minus 10. I'm going to combine like terms. I've got sine squared theta minus 3 sine theta minus 10. Okay? You see what I did right there? Okay? Let's pause it right there. Part 2 coming at you next. But go ahead and pause right there. Rewind it, redo it if necessary. Stick with this, guys. It's going to pay off in the end. All right, we'll see you next time.